Hey everybody, it's Mike here at Game from Scratch. Today we're going to be talking about the Rust programming language. Now, in the game development world, C and C++ have long been dominant, although C# is definitely gaining ground. And there are a number of popular scripting languages such as Lua or JavaScript that are also quite popular, but C++ has just kind of held on to the crown as the primary language for game development. And there's a couple of reasons for that. First off, C++ got very popular in the beginning because it was backward compatible with C. And C was basically the lingua franca of systems level programming. So if you wanted to get close to the hardware, if you wanted to have absolute control over your program's lifecycle, over memory management, over all of the things that help determine exactly how your game or your application is going to to execute, you generally used C or C++. And that's where Rust comes in. Rust is a systems level programming language that kind of aims to solve a lot of the same problems that C++ tries to solve, but it has the benefit of learning from 30 years of C++ development. At this point in time, C++ is almost multiple languages in one. Originally, you've got the C layer underneath it. You've got the original C++. You have C++ 03 version. You get into the templating language, which is basically an entire programming language built on top of C++, and then you adding templates changed the way that all of C++ worked, and then that in turn influenced everything, and you have then basically 5 generations of programming language support in one language, and that leads to a lot of cruft, and that also leads to a lot of complexity. So at this point in time, the language spec, I think it is fair to say that C++ is the most complicated language out there. That is to say that the poor bastards that have to write C++ compilers have to follow more rules than any other programming language out there. The language spec is just astronomically huge at this point. So a clean start is definitely appealing to a lot of people. But I'm mentioning Rust right now specifically because it just gained a lot of traction last week, July the 23rd. This tweet came out. It's finally happening. After 30 years of pro use, 20 of which quite reluctantly, I am officially done with C++. Only maintenance from now on. Everything new will be in Rust language. Thanks Rust team for refining modern concept in such a practical, elegant system. I love it. Now, why the hell should we care about this anonymous tweet? Well, it's not anonymous. It was Andrea Piston. But who is Andrea Piston? Why do his words carry any weight? Well, he is the CTO at Ready at Dawn. And Ready at Dawn Studios is, I don't think I'd say AAA game developer, but they're definitely an A game developer. They have made a couple of games, some of which you've definitely heard of. The Order 1986, God of War Origins Collection, various different God of War games, Okami. So this is not a nobody studio. These guys are making, games that sell millions of units, and they're moving over to the Rust language. And that got me interested. I love programming languages in general. I love game engines in general. So I decided to jump into the Rust language world and see what's what, see how interesting it is for game developer. What I was going to do is basically do a rundown of the various different options that are out there. We could go through some of the different features and libraries and frameworks available for the Rust programming language, and I'd break it all down for you in this video. Now, the cool thing is I don't have to. Someone else already did all the work for me, so I'm just going to piggyback on their work, and I will show you a website that nicely illustrates what the Rust ecosystem is like for game developers, and you can check it out for yourself. Now, before we get too far, let's look a little bit at Rust. Now, you can find Rust looks a whole lot like, well, to me, it looks a lot like Kotlin, to be honest, and Kotlin looks a lot like Swift. But I think we're hitting a convergence point. Basically, all programming languages are starting to get pretty samey. So the syntax is getting pretty similar. The way things look and feel in this day and age, they're starting to get pretty similar. So this is obviously a C++ inspired language, and you can see it there. But then again, Kotlin is a C++ inspired language. Swift is a C++ inspired language. There's a lot of copying going on in the world of language development, and that's a good thing. We're getting to a convergence point where these programming languages start to look pretty consistent across the board. Now, there are a lot of features specific to Rust, and I am by no means a master of this language, so I'm not going to be getting into a lot of that. But what we will do is cover some of the game development frameworks available, and then I will finish the tutorial off by showing you how to set up a Rust development environment. And this will actually showcase why Rust is so appealing compared to, say, C++. In C++, setting up a build environment isn't always the funnest thing. The linker environment, the build process is not the cleanest thing in the world. But when you start seeing the way things work in Rust, you're going to covet it just a little bit. I guarantee it. But anyways, what are the feature points of the Rust programming language? Well, you see right here, basically zero cost abstractions. And zero cost abstractions is basically the mantra of C++. The whole idea behind C++ is they don't want to add weight to the requirements. So if you want to have a new feature in the language, it has to basically cost nothing from a performance perspective or be completely optional. And they're kind of coming to the same way. So whenever they add a layer of nicety to the programmer, they want to make sure that there's no performance hit on the back end for it. That's one of the design mantras there. Move semantics, that's kind of like the copy constructor stuff that's been added in C++. It's 11 and our R value, which was added in 14, I think. Guaranteed memory safety, threads without data races, trait-based generics, pattern matching, type inference, minimal runtime, and efficiency bindings. So if you're looking at that and thinking, wow, that sounds a whole lot like modern C++, like the kind of stuff being spec'd in C++ 14 or C++ 17, well, you're right. Rust is very similar in scope to C++. Modern day C++. It just doesn't have all the legacy cruft that C++ does. Now, where I was going to go with all this was I was going to do a whole bunch of research again on what frameworks and engines, etc., are available for Rust. And I don't have to, because I discovered this lovely site. In fact, actually, people on my Twitter feed informed me of it when I asked the question. So thank you, by the way, you guys, for the feedback. But what we are looking at is a site called arewegameyet.com. And this is entirely all about getting started with Rust. But the cool thing is they basically break down what's available in different categories. So if you're interested in getting a game engine for Rust, you can see here there are 9 crates available. Now, a crate is essentially it's like a deployment / library bundled together, kind of like NuGet or apt. It's along those lines. It's a package, or sorry, NPM. It's a package and library all in one, and it makes deployment very, very simple, which we'll see in a second. So if you're interested in getting a game engine for Rust, here are your options. And from what I found, Piston seems to be the primary one, and this is the one we're going to use in our actual example. And if you're interested, you can go to their websites from here. So just click that little link and you'll bring up more details on that particular website. But we'll go back here for a second. You see there's also a data-oriented game engine called Amethyst, Corange RS, GGEZ. That's another one I looked at. So basically the two I personally checked out were Piston and GGEZ, which both look actually pretty cool. Then we got Turbine, Caper, Mold 2D, Nitro, and Rust SDL2. Now, speaking of SDL2, you'll also find over here, you've got a number of 2D rendering libraries, like so. And we also have, I thought there was a dedicated section to binding, but see, you got here. So if you're looking for a UI library, there's 3 available. ECS system, there's 9 available. Math library, there's 6, etc. There's a whole bunch of stuff here available, and you'll find that a lot of the most popular C libraries, because of the easy C++ bindings, are quite available to Rust developers. And that's kind of when we go all the way back to this guy. He's basically talking about, he's not going to abandon his entire existing code base, but he's going to do a Rust layer over top of it and then slowly start weaning those out. So you can easily start migrating your C or C++ libraries over to this, or you can easily get Rust language bindings for your particular language of choice. But if you're looking specifically at game development, this is where you're going to want to start. You're going to want to jump through here, but this also has some details on getting things up and running. So this is pretty much what I was intending to start working on, kind of a pale version of. You can also find out some of the games that have been invented using Rust. Now, what you're going to find here is there are no major commercial games done with Rust. That's why this Ready at Dawn adoption is a pretty big deal. But Rust is definitely a language worth checking out, and it's a language I am still checking out myself. Like I said, I just kind of got really interested in Rust, but what I will show you is how you can actually get Rust going on your own system. Now, first off, you're obviously going to need Rust. Now, let me just unfull screen this guy. Something weird is going on with my cursor. One second. Okay, here we go. So now you're going to want to grab Rust. What you're going to do is go to the Rust homepage, which is rust-lang.org, and you can just go ahead and do an install. Now, if you have the Linux subsystem installed for Windows, or you're on Mac or Linux, you can basically install Rust using this curl command right here, or you can just use the installer if you're on Windows, which is what I'm going to do. As you saw, it's 6 megs in size. So this is a pretty trivial install for the most part. Yeah, we're going to run that anyways. Security be damned. All right, so we will proceed with a default installation. And this will go ahead and basically, this is kind of an executable around this command right here. So it's going to go off and grab, looks like we're at 50, 100. This only takes a few seconds, but this is pulling down the key things we need, specifically Rust C, which is the Rust compiler, and Cargo, which is, actually, it's kind of hard to explain Cargo. Cargo is kind of awesome. It's a combination of build manager and package manager in one. I think it's probably the safest way to put it. It's a lot like using NPM if you've ever worked with Node. So we'll let Cargo come on down. And for this particular example, I'm going to be using Visual Studio Code as my IDE of choice. You can obviously use whatever you wish. But let this run. Actually, while that's doing its thing, sorry, this is so slow. Anyways, I'll let that run for a few minutes. I'll just pause it and I'll return in a second. This is a classic. Anytime Windows seems to be slow, look to your services. Oh, look, it's Windows Defender. God, I hate you, Windows Defender. Anyways, that's why we're taking some time here. And I swore I shut that down earlier, but I will go shut it down again. Okay, we are back. So that should take almost no time at all, unless you have Windows Defender running, which is one of the worst pieces of software in the universe all of a sudden, which is weird because Windows Defender used to be amazing. So anyways, my rant aside, we should be up and going. Why is my cursor going insane? I don't know. I'll just shut this all down. Maybe it's something to do. No, it's still going on. All right, there's something definitely going on with my computer as we're doing this, but here we are in Visual Studio Code. Now, next up, what you need to do is go ahead and install the Rust extension. What you're looking for is Rust RLS. Let's go ahead and install that like this, and it is good to go. So now it's going to ask for a reload. I'm going to shut that down for now because we're going to come back to this. So next up, let's fire up a terminal. So, and we'll go into my favorite directory, temp directory, and now we're going to go ahead and create our first project. And to do this, you can use Cargo. So let's first off make sure that Rust is working. So hey, look, Cargo works. And what we're going to do is Cargo new, and we'll call this Rust demo, and then -- bin. So what this does is creates a new project for you. If we go into Rust demo, we will see here is our new project. Now the key thing is this .toml file, and now let's open that up in Visual Studio Code. So here you see, so our source code is in here. Our main.rs is available right there. So what you want to do is actually open that one up, and it will pop up this RLS not installed. Install, and we want to go ahead and say yes. So that will basically now set up, and Rust should be good to go. Now it's going to actually be installing, so keep an eye down here. This takes a couple of seconds for this to run. But once the Rust language services are installed, you should now be able to get full IntelliSense and all that kind of stuff going on. Here is your hello world of Rustitude. We should be able to do I think it's a run task. And what we do is Cargo run, and you will see this will execute our example. I named my guy poorly. That's my bad, but it's just a warning, so we're fine. So you see right here, hello, world, and done. So that is just creating and running your first Rust program. So getting up and running in Rust is trivial. Now we'll look at a little bit more of a sophisticated example by going into their actual Piston examples, and we'll show you how to get those up and running. Now, first off, we're just going to head on over to their website. I'll throw this link down below, along with the one to all of the various different resources that we've used today, and one to the Rust language homepage. Should be everything you need to know to get up and started. But basically, just come on in here to the examples. Just click to this guy and clone that repository. I'll go back over here to our command prompt, and we want to do a git clone and paste that guy in. This basically just brings down the examples for us. Let's switch into the Piston examples folder and open that up in Visual Studio Code. So this now is a more advanced example. Coming here to source, you can see there's a couple of different examples here, such as this cube. And the key guy here, the key thing to understand behind Rust is this package manager, that cargo thing that's going on. We'll let the Rust language service parse through our thing. This is sort of like the IntelliSense parsing that you see in Visual Studio Code when you first open a project. Doesn't take too long. But we'll head on over here. The key thing you're going to want is this toml file. Now this is basically your project file. Now that gets annoying, go away. And the key key thing here is your dependencies. This is basically a combination of package manager and linker all in one. This is basically telling Rust, these are the following repositories that I am dependent on. And it will automatically go out and grab all of those when we go ahead and do a build. Now, let this run for a second. I'm going to pause it, and then we'll go ahead and build this project. Okay, Rust Language Services is done doing its thing. You'll see here are the various dependencies of our project. So now when we go ahead and do a run, so here I'll hit F1, bring up my palette bar, run task, and what we want to do is a build. And what this is immediately going to do is download, I actually already did a run of this, so it already downloaded them all for us. So now all it's got to do is compile all of those libraries and our code itself. So this cargo build process, again, is a package manager. It goes across the internet and downloads the various dependencies you've got declared in this dependencies section of your TOML file. And then, of course, it is your build system as well. So it's compiling your Rust code, or it's calling out to Rust C, which is doing the magic for you. So here you see we're compiling all of our various dependencies here. You can hear my fans whirling up a little bit in the background. And this will take a bit of time. You see there's a fair number of dependencies, but it's not outrageous. So we'll head on back over here to some of the code. So this is the code for, I think it's creating and rotating a cube in 3D space. And you'll see if you've worked in any modern programming language, you're going to immediately recognize a lot of the constructs in Rust. So you've got your include system here, same as import in Java or C# or pound include, sort of in C++, same basic process here. You've got, this guy's a bit hard to explain. This is anything that ends with the bang or the exclamation mark is a macro. It's a lot like a C# or C++ macro, where you can basically do a pound define and do some code that will be replaced with the function. But it's a little bit more complex than that. But a lot of times you'll do it for things like variadic function definition. So if you have a bunch of different my brain's not working, parameters to the function you want to call, you can implement them using this macro system. That's why you'll see print line, because printf takes a variable number of arguments. Well, you can implement that using a macro system, but for the most part it looks just like a function, except for it has this exclamation mark marking it at the end. Here is your traditional entry point. You mark out a function. So functions have the same scope operator. You still use the semicolon to terminate a line. A function is declared as fn. You'll see here variables are declared using the let determiner. If a variable can change, you use the mute or mutable marker right here. But otherwise, you'll find this code looks a whole lot like any other programming language you're used to. You've got references. Yeah. So I'm not going to get into a huge amount of detail on Rust coding specifically, because I have no means claim any level of mastery at this point in time. But you'll see our code is now done and run. So we can now hit F1 again. And this time we will instead do F1, run task. And what we want to do now is a cargo run. One sec. And what you're seeing here is we have multiple different binaries in this example. So if you come back here, you'll see instead of just one executable, we have 10-ish. And if you go into your TOML file, you'll actually see that they're defined that way. So there's this binary file, this binary file, this binary file. So you're saying I have like 10 mains inside of this project. So instead what we're going to do is drop back to our trusty command prompt, and we'll run it this way. So we can do cargo run, and then we just specify which bin profile to use. So you see here we have hello world, etc. And what we want to use is, I think it was called cube. Go ahead and run that, and there you will see our cube. So we could also have done cargo run -- sprite. Oh, sorry, -- bin sprite. And there is a Rust sprite demo. So that is, in a nutshell, getting Rust up and running, configuring an external library for game engine development. It's pretty sweet. The systems and setups work pretty much as you would expect it. Now, this is a language I'm going to jump into a little bit deeper on my own free time. See what I actually think of coding in Rust as opposed to C# or C++. I don't have enough experience to really give you an opinion there. I've only just scratched the surface of what it's capable of. But I do like the ecosystem. I think you can get up and running in Rust. Basically, if you were a brand new developer, you could follow the tutorial I just did, and now you're at least at the point where you're going to be able to start writing code. In C++, I don't think you could get up and running and using an external framework or a game engine or something with anywhere near this level of ease. And that's to make sense. It's a newer game engine. It's got a modern workflow tool set, but I like what I've seen so far. I will be interested to see what you think of Rust. Are you using Rust already? Have you got your eyes on Rust? And the kicker is there is no major game engine support, and that's where the mass majority of people are going to be. Most people are still going to be working in Unity or Unreal Engine or Default or Godot, etc. And in that case, realistically, the language doesn't matter a whole lot, although you could still probably start making your extensions using Rust if you preferred. I believe you can, in Godot, for example, use GD native with Rust if you wished. But if you're working at a much lower level or you're rolling your own, is Rust an appealing looking technology to you, or is it just another C++ wannabe in your world? I'm interested in hearing what you think of Rust overall. Now, once again, a big shout out to, crap, I closed that window already. But again, check out those links. I will throw them down below. That resource for basically, are we Rust yet? Are we ready yet? Are we Rust yet? And basically, that website was just a wonderful resource for the frameworks and libraries, etc., that are available for Rust. So if you're looking for a place to start with Rust for game development, definitely check that one out. All right, that's it for now. I will talk to you all later. Goodbye.